In example 6, we're working with a random variable x, which follows a binomial distribution with 20 trials, and the probability of success on each trial is 0.4. So we're doing 20 trials, and x is going to be the number of successes that we've got. Well, it might be useful actually to have a look at what this distribution looks like. So along the horizontal axis, I've got the possible specific values that x could take. So we could have 0 successes all the way up to 20 successes. So it goes from 0 up to 20. The height of each bar is the probability of having that specific number of successes. So for example, the height of this 4 bar tells me what's the probability that I have 4 successes in the 20 trials. And it's interesting to note that the highest bar, the most likely x value, is 8, and that's because that's 20 times 0.4. If this is basically saying if we've got 20 trials and the probability of success is 40%, then on average I'd expect to have 8 successes, which is why that's the most likely outcome. And also it's worth noting that these bars don't show up. That's because these are just really, really small probabilities. So for example, the probability of x being 20, that's all of the trials being successes. That has a probability of 0.4 to the power of 20, because it'd be success times success 20 times. And that's really, really small probability, 0.4 to the power of 20. So in part A, we're asked to find what's the probability of x being less than or equal to 7. So if you were to say this in English in words, this would be what's the probability of having 7 successes or fewer. So sometimes I think it helps to draw a little diagram and work out what x values do we want to include in this probability. So we know that we can't have lower than 0 successes, that's as small as possible. And obviously it would go all the way up to 20. Now we want 7 successes or fewer. So that means we want to include 7 and go down to 0. So if we were to add up these probabilities separately, we would want probability of x being 7 or x being 6, so we'd have to add on the probability of x being 6 plus all the way down to the last probability that we'd need, which is the probability of x being 0. Well, we could work out each of these probabilities using our formula that we learnt last video. But actually our calculator has an inbuilt binomial function. So you need to go on Menu and then Statistics and then Dist for distribution and then Binomial. PD, the first option, F1, tells you a specific value of x, specific probability of a value of x. So for example, if I wanted what's the probability of x being 7, there being 7 successes, I'd put x is 7, number of trials is 20, the probability of success is 0.4, and that would tell me that the probability of having 7 successes is 0.166. Well, we don't want that, we want a range of x values. So we're going to go on Distribution, Binomial and CD. C stands for cumulative, which is basically just adding up multiple probabilities. Now we're going to put our lower as 0, because we want the probability of x being 0, all the way up to the probability of x being 7, and we want to add together all of those probabilities. Now your calculator will include the lower and the upper values of x, so we're going to include 0 and include 7. So that's going to do 0, probability of 0, plus probability of 1, plus probability of 2, all the way up to probability of x being 7. And we're going to keep our number of trials as 20, probability of success is 0.4, and we get 0.416. So this here is 0.416. Now you don't even need to show any working on your calculator, because the examiner knows that you've got this function on your calculator. So in part B, we're going to do probability of x being less than 6. So again, it's worth writing down some values. So number of successes, let's draw them out. Now this time we want x being less than 6. So we want less than 6 successes. So we don't want to include 6. The biggest number that we want to include is 5. That's the first number that's less than 6. And again, we're going to go down to 0 because 0 successes is less than 6. So this time we would do the probability of x being 5 plus the probability of x being 4 plus all the way down to the probability of x being 0. If you were to see this on a bar chart, then that would be equivalent to saying we want to add up the probabilities on the bar 5 all the way to the left of 5, all of these probabilities to this bar of 0, and work out what's the probability in this region of our bar chart. Well, again, we're going to use our calculators. This time we're going to just set our upper as 5 because we want to only go up to 5 and include that probability. Leave number of trials and probability is 20 and 0.4, and we get 0.126. And then finally, in part C, we want the probability of x being greater than or equal to 15. So let's write out some numbers. So 11, 12, 13, 14, 15, 16, 17, all the way up to 20. So we want there being 15 successes or more. So we want to include 15, and we're going to go all the way up to 20 successes because that's greater than or equal to 15. And on a bar chart, if you wanted to look at this on the bar chart, this would be the region which is 15 or more. So we would want to count up how much probability is there in this region of the bar chart, add up these probabilities. So we can do that here. I'm not going to write out what the calculation would be, but I'm just going to go straight to using my calculator. So this time I want my lower as 15, and I want to add up all the probabilities up to 20. And that's going to give me that small probability here, 0.00161. So it's quite easy to use your calculator to do this. The biggest mistake is that people don't forget to not include values when the inequality is strict. So it's really common to see people accidentally including 6 as their upper, but actually our upper is 5.